really cool. I got to go to DEF CON. I just got back from DerbyCon 2 days ago. Actually, I got RT'd by DerbyCon wearing a T-Rex costume at the final concert with infected mushrooms, so that was pretty cool. Current projects that I'm kind of focusing on. I'm going for the OSCP. Have any of you guys heard of that? Yeah, it's good stuff. You really get a deep dive into like the technical aspects of hacking and Windows and all kinds of stuff. You learn so much for it. And essentially it'll make me a better blue teamer in the end. And I've ran the idea by just loads of people, and they all thought that it was a good idea. So it's like, let's go. I'd kind of like to use PowerShell to automate a lot of the deployments of our Windows environments and stuff like that. And lastly, there's the SOC style lab I'd like to do for DakotaCon. There's a lot of CTFs for people that aren't in the defense area, and I'd kind of like to hone that in and make it nice for DefSec. Why defense? Red teaming is absolutely overrated. Just kidding. It's pretty cool. For example, when I taught a few modules at Gen Cyber, any title that had exploiting, hacking, that kind of deal, the class was completely full. Like I had 40 people signed up for like one of my classes, and I had like attacking wireless networks or something like that, and I was like, these are high schoolers, whatever, right? And then I went to Black Hat, same deal. If there was any of those briefings that had NSA, CIA, had hacking, red teaming, any of that, the class was completely full. So defense, you kind of have an advantage there as far as like the market share and things like that, and the amount of people that are going into it. However, you do need to know how the offense works to become a better blue teamer and stuff like that. In fact, Jason Street, I don't know if any of you have heard of him, he kind of recommends if you ever do want to get into OffSec, always start in defense. And I was just watching a podcast or a webcast from John Strand that he recommended, like learning all your concepts, your defense concepts with like Windows, Linux, Python, and all that stuff before moving on to your hacking stuff. So why Windows? Most of the world runs on Windows. I think the number right now is around 80% or so. A lot of the people I talked to, or a lot of the briefings at DerbyCon this year were all about attacking Windows, the Windows domain, weaknesses in Active Directory and things like that. There's Windows it's a really good skill to have. There's a lot of people that I talk to at Trusted Sec. They spend most of their time attacking like Active Directory and things like that. And they might find a Linux box or two that might have a cred on it, like vuln scanners and stuff run on Linux. So it's good to know that skill too. But that being said, know how to harden it. Otherwise, they'll use the vulnerability scanner against you, and then they can, kind of get your creds and stuff. So why DefSec? You get real life enterprise network defense that you're probably not going to find in the classroom. You're going to go over a lot of various different concepts and things like that. But you're not going to get the experience of having services, having to keep up your services, defending your networks from live hackers, which the OffSec Club usually does. Takes care of that part for us. It's very good at simulating a business environment. We bring it together IT and business. So like there's a few various injects like that your CEO might have you do, like, hey, how's our network doing, that kind of deal. You have to write a report and kind of show them how your network's doing and things like that. It looks extremely good on a resume. It shows that you're passionate about the subject, and employers will be all over you for that. And lastly, networking, and if I haven't said it, networking. There's this tendency to get stuck in this thing I like to call the DSU bubble, where you kind of forget that there's an outside world and things like that. And when you go to these competitions, you meet all these people. It really opens your eyes as far as to what's out there. And there's really cool people that you get to meet at these competitions, because they're looking for people to go join their enterprises, and they go, where do they go? They go to NCCDC, Ice Age, all these different competitions where they know the talent is at. Lastly, just to kind of give you an idea of some of the people that show up at some of these events. Earlier this year I was in Orlando, and there's 3 CIA guys there. All of them, their name was Prom. And then I was at Black Hat 3 months later, and I found one of the guys whose name was Prom. His badge now said Jon Snow, and he was from Blizzard Cyber. Super interesting. And then I was like, "Are you from the CIA?" And he's like, "Hey, how's it going?" And then we just had a conversation for a while, and it was cool. Some of the terminology that we're going to be going over. The first one is going to be RDP. This is the remote desktop connection service that's going to be on your computer. Actually, they just released something called Bluekeep, a public module for getting a remote execution on a Windows computer. I think 7, SP1, 8, Windows 8, all the way up to Windows 10, I believe. So, yeah, let's see here. There's going to be quite a few of these people that are... So Rapid7 just dropped an exploit for Bluekeep. I'm going to go throw that at the internet for a few hours. That's basically what all the script kiddies are doing right now. So yeah, RDP, that's a huge service that you have to keep up during CCDC and stuff like that. DNS, domain naming service, mapping 192.168.1.x to memeserver.lan. MS SQL, that's Microsoft's database service. You're also going to hear terms like MySQL, SQL, all kinds of different versions of SQL. For Microsoft specific, it's going to be MS SQL. HTTP, if you don't know this, honestly, you might as well just leave right now if you've never heard of HTTP, the door's that way. HIPS, host-based intrusion prevention system. This is just going to look at the traffic that's coming into your computer and kind of block exploits and things like that. AV, antivirus, like Windows Defender. They're going to be sitting there looking at exploits and stuff like that, or signatures and things like that on your computer and do a lot of other stuff. MMC, Microsoft Management Console. This is a really, really neat tool that we'll be using. You can kind of consolidate a whole bunch of Microsoft tools into one view. And Telnet, super bad transfer protocol. If you find this on your computer, just, or your network, nuke that off as soon as you possibly can. And finally, SSH. While SSH isn't really native to Windows, it's more of a Linux thing. I was forced to put this on here only because of this guy. One year he decided to put SSH onto a Windows box, and I still don't know why on earth he did that. I think some guy that there's this guy named Kevin who works at TrustedSec now. He made a script during one of our competitions to actually exploit all this SSH stuff, and it broke because it was Windows, and he didn't know what was going on. He's like, his mind was kind of blown there. Basic security hardening on a local machine. These are things like looking at users. Do you need these users on there? Should you does this person still work here? Or are they a vendor that no longer work for us? Passwords, make sure you have good passwords. And you're not using things like NTLM on your network. Firewalls, make sure your computer has a firewall. It's typically going to be one of the first things you want to check on your computer, is if that firewall is on there and only allowing certain services and stuff to access your host machine. Users and groups, kind of look at that, see what people are in your groups. Auditing, you're gonna have stuff that's going to be sent to your SIM, and for your analyst to look at, you're going to kind of want to have your auditing all set. Local security policy, this is kind of what we're going to be using in our local Windows 7 machine, just because it's not connected to a domain. This is a really good intro way to do this. Adware, you're going to want to check your computer and make sure that's not on there. Pretty sure I threw some on this test box. And scheduled tasks. This is good for persistence. We could spend an entire day on persistence and things like that. This isn't the only way to do persistence. But yeah, so how many of you have actually logged into flash.diffsec.club yet? Anyone?
Or H5.
Okay, you don't have to yet. You kind of can if you want to make sure everything's ready by the time I'm done with all these slides. Basically, users, ask yourself, does this user actually need access to this machine? If the answer is no, then, does Sally from accounting really need remote desktop access to the domain controller? Probably not. Sally from accounting probably doesn't know computers very well, and she's one of the people that's more likely going to click on a phishing link, and someone can kind of dive in there and be like, or a hacker can kind of dive in there and if they have a computer exploited, they're like, oh, hey, they run Bloodhound on the network and they find they can RDP to the domain controller. That's kind of a bad thing, ever so slightly. Disable the local admin on a domain, on any domain accounts. This is because the password, I think, is stored it's going to be stored in memory and stuff like that, and you don't want that. Or use LAPS. That's basically a protocol that randomizes all the local admin computers, all the local admin user accounts on all your domain computers, and it stores that on the domain rather than having it on your computer. So, yeah. Make sure to follow the principle of least privilege. Essentially, only give people the privileges that they actually need. Passwords. Implement reasonable and secure policies. These are things like complexity requirements, although that's kind of up in the air at this point, whether we need those or not. I think NIST kind of recommends going with the whole correct battery horse staple concept. If you haven't heard of it, look it up. Basically, you just put 4 phrases together and then you have a good password. Password age, you don't want to, this is also up in the air, whether it should be good or not, or whether we should have password ages or not. I think right now, the last company I worked at, they did 90 days. Password history, make sure users can't retype in old passwords and stuff like that for their new password. And lastly, making sure they have a password. Run a tool on your network to make sure to kind of do auditing on all the passwords on your network. Password length, I personally would recommend having at least 10. You can do 8, but still not as secure as 10. Having a account lockout threshold, I think the current NIST recommendation is after around 100 attempts or something like that, and that's going to be found also in your local security policy setting. We'll kind of go over that in a little bit here. Groups, this is where you assign different users access to different resources, things like who has access to RDP to that computer, who has admin access, who can telnet to that computer. Hopefully that's not a thing. That kind of deal. Firewalls, make sure those guys are turned on. There we go. Firewalls, make sure it's turned on and there's not an any rule that allows everything into your computer. Basically, one of the first things you want to do when you go on a computer is you want to block anything that doesn't match a rule. You want to block it and make sure that it can't get on your computer. So it's kind of a little bit of how the firewall works. So this is kind of how your enterprise network is going to look. So basically what a LAN is you're going to have a LAN. You're going to have all the computers connected to this LAN. It's called a local area network. All these computers are going to be right here. And then hopefully your network's going to have a firewall like a Palo Alto or a Juniper, or where we commonly use this thing called pfSense. It's a free open source kind of firewall. Basically what we're going to have here is 2 layers of defense, essentially, ideally. So you're going to have a firewall right here, and then on your LAN, all the computers on your LAN are going to have a host-based firewall, which we typically call Windows firewall. There's a lot of other services that take over Windows. They take over the firewall and have their own things attached to it instead of just that. So auditing, that's kind of a huge deal. I kind of mentioned earlier, a lot of there's going to be things like system information event managers. It's essentially going to be a centralized logging system, and it's going to have certain correlation rules. And there's literally people they're called SIM engineers that are dedicated to collecting logs and putting it in a view that's going to be useful to your analyst on the network. So you want to make sure you have the correct auditing in place. Things like we'll go over Sysmon. Eventually having Sysmon on your network, and there's a whole lot of rules that you need certain event IDs, and you have to make sure that those are enabled and things like that. This is kind of how you do your forensics. If you want to see what a red teamer did on your computer, you can either look at Windows Event Viewer, or preferably you're going to look at your Sysmon logs, because that's a lot cleaner than your Windows Event Viewer. We'll go over that a different day too as well. Let's show you our PowerShell command line logging. I'll tell you a story about that, but I'm kind of running low on time here. That's kind of what that looks like. event viewer, you can have your Windows logs, application and service logs, your subscriptions and stuff like that. We're not going to be really using that today, I don't think. Yeah, no, I didn't set it up. Okay, so this is kind of the tools we're going to be using. I'm going to skip to the next 2 slides and we'll come back to this. The reason I'm going so fast is just because we have as much lab time and stuff like that, and then you can actually learn. And then I'll post most of these slides either on my website or somewhere else, probably our training folder as well. So resources, go ahead and follow me on Twitter. Maloha Jr. Basically, that was my dad's call sign back in the day. He was an F-16 pilot. He just retired a few days ago, and I actually went to DerbyCon instead of going to his retirement because he told me, Nick, it's more important that you go to DerbyCon than show up to my retirement. And I was like, dang, I love you, Dad. Wireshark.life, I don't go there yet. I still have to build that out. Please don't go there, actually. SwiftOwnSecurity.com, this guy has like everything Windows, basically. They have a really, really nice standard sysmon config that a lot of people use. IronGeek.com, follow this guy on Twitter. He posts a lot of the videos and stuff from all these conferences. I think he basically had all the videos from DerbyCon posted as well already. Cyber Operations by Mike O'Leary. This is a really good one. Wish I had this when I was a freshman. It's got a whole lot of good stuff. You can read the slide and kind of see what it's got. You can, I bought this for like $70 at Black Hat, or if you're like one of those people that never wants security clearance, head over to pdfdrive.com and type in Cyber Operations by Mike O'Leary. Yeah, don't actually do that. Windows Internals. This is another really thick book. Some guy made it in collaboration with a whole bunch of Microsoft employees and stuff like that. If you ever want to get into making malware or really understanding how the internals of Windows works, get that book. It's like $30 on Amazon. Or go to the previous thing I just talked about. So yeah, another really, really good resource is blackhillsinfosec.com. I use these guys all the time. They've got loads and loads of really neat webcasts on all the stuff that's going on in the industry. And basically, I can go through this later. So yeah, here's kind of so now just log on to flash.defsec.club. And this is we're gonna have we're gonna have a Windows box for you. And it's gonna have a scoring engine on that Windows box. And we'll kind of go over a few things and what to do, what to look for when you log onto a Windows machine, and kind of consolidate all the stuff that I just presented in all these slides for you. So yeah, some of the tools we're going to be using: Windows Firewall, local security policy, Microsoft Management Console, PowerShell, local users and groups, Komodo Cleaning Essentials. That's a really nice one for finding which process is using has a shell in your computer. So let's go wander over there. Okay, if any of you need help getting to this point, just let us know. There's a whole lot of people that are around here that could help you, or I could run over there quick.
Here's a really legit question. Do you guys actually have Flash on your computers or not?
Oh, yeah, that's a good one. We do HTML5.
Or you want to show me HTML5?
Yeah, so you can also go try the new portal right here. That's going to take you to the HTML5 interface.
Should also just be H5 or HTML5.defsec.com.
Is it H5 or HTML5? I thought it was.
H5.
Okay. I got an error when I tried it last time. That's kind of why I didn't. Oh, nice. Okay, that works too. So to get onto the IA lab, that should just be your network password, the thing you type in for Wi-Fi and all that good stuff. I don't know why I have about 1,000 machines on here right now. Oh, okay, that makes sense actually.
Just go to VApps.
Is it going to be this one? Yes. How many of you need help getting to this point if you're following along in the lab? Flash.devsec.club or hd5.devsec.club. Okay. If you do not have, how many of you couldn't get the Flash to work? Okay. So we're going to do this from the Flash interface. For those of you that don't have a Windows VM, if you don't have a Windows VM, I'll kind of go over how to add that. You were supposed to have it automatically, but you know, not everything is magic. Okay, so if you didn't come here last week, then that's kind of the problem. But that's a problem. Not a problem, you know, but yeah. So how you add that is you're going to go over to Add VApp from Catalog, and then you're going to go to My Organization's Catalog. It's right here. Go to All Templates. Scroll down a ways, and you should find this guy called Windows Defense 101. Again, if you got the Flash interface to work, go ahead and go to Add VApp from Catalog. Go to All Templates and find Windows Defense 101. Let me see if I can't scroll in there for you.
But either way, you know. There's something to bring. Make it fair that if you guys do the attempts, they will be auto-deployed to you, so you don't have to worry about it. You, let's go. Great, be You can do it. It's just not a full set. You gotta go to the catalog and you gotta correct it again. It's like, yes. Please, add me out. Or somebody could have stood up and said, it would have been here. They worked so hard to put it on. I don't know.
Oh, look at
Alrighty, raise your hand if you're doing the lab and you're still having issues getting to this point. Anyone? Alrighty, I'm going to give you all another 60 seconds and then we'll go ahead and kind of dive into the VM and what we want to do once we get on there. Alrighty, it's been approximately 86 seconds, so let's go ahead and get started. So go ahead, click on this guy. You can double click on it, or if you're really fancy and like to take your time doing stuff, never mind, that doesn't work. Or wait, no, you can go like this. Pop out console, call it good. So you're going to come up with this thing called Windows 7 Updated. And you should get this nice little title screen up here. Let me try to zoom that in for you. Move. Okay, so the first thing you're going to notice when you come up onto the screen, there's a really, really strange banner title. Like, what sysadmin in their right mind would actually make a banner title like that? Like, unless they're super unprofessional and really dumb. So yeah, So you click OK on that one of these days. There we go. You're going to notice there's like five different accounts. You're going to have your administrator. There's a really weird account called Backdoor. I don't know what that's doing on there. Maybe that's one of the users we need to audit. There's DSU. There's going to be John. That sounds like a perfectly normal name. Then there's going to be your guest account. So you're going to want to go ahead and click on the DSU account. And the default password is going to be password 1 bang. If you don't know, that's the default for all the IA Lab virtual machines. So basically, that's capital P ASSWORD 1 exclamation point. I'll kind of write it out here a little bit for you so you can see what it is. Oh, you come on here and you notice there's some really weird PowerShell stuff running. I'm kind of wondering what's up with that. Okay. Go ahead, close out of that stuff. So for those of you that didn't get the password, it's password 1 bang. Okay, so does anyone need help getting onto the console screen at all? Perfect, okay. So that's going to be the password 1 bang for most of your admin machine, or most of your machines on the IA Lab. Yeah, so go ahead and open up this to-do list. You're going to be greeted with this thing saying, save us. Thanos has wiped out half of our defense. Oh gosh, that's a bad typo. Has wiped out half, pretend it says half, of our system defenses. You must bring them back online before a cyber attack occurs. Yeah, so you kind of read through this. This is going to be a lot of the things that you're going to need to do on the machine. That's not all of them, but it's quite a few. And I'll kind of walk you through where to start on all that and what stuff to open up. So yeah, that's kind of what you need to do. To see where your status as far as how far you are at securing this box, there's probably 1,000 more things you could do to secure it, but these are the things that we're scoring here. So you're gonna open this thing up, and it's called. This was made at Texas A&M University for this program called Cyber Patriot. Some of you might have been part of it back in the day, which is all the best for you. Nice. Yeah, it's just gonna go through your computer and check all the stuff, see what you have. A bunch of stuff I inputted and whatnot. They did a really nice job on it, and I thought it would be great for a first time. Windows Defender people. So yeah, so the first thing, so pretend I didn't just show you all this stuff. The first thing when I log onto the box is I see this really ugly crap called high contrast theme. So I'm gonna get rid of that just so it's not super distracting and I don't miss stuff. So let's see. Go to Windows color. How did I do this? I think I clicked on that. Oh my goodness. I locked myself out of saving these themes. How did I do that? Oh, never mind. There we go. Got some good old Windows Classic going on. If any of you don't know, if you put your Windows 7 machine into like this really Windows XP-ish theme and things like that, it's going to make your computer run a lot better. There's a setting for that. Rather than having the super high-tech, fancy-looking Windows 7 stuff, even though it's not high-tech and fancy. So yeah, I see that and I'm like, okay, I remove that. I might do that actually later just because it's not necessarily the biggest priority. Is the firewall on? So we're gonna go to Windows Firewall. Boom, no, it's not on. So we can go ahead and use recommended settings. We could probably spend an entire day just on the Windows Firewall. So yeah, so now our firewall's on. Was it doing us any good? I don't know. Let's see if the score report is updated at all. There we go. So our firewall's been set on, and we're so far 8.33% to securing this machine. Oh, what was that script that just popped up? Why is my mouse moving absolutely everywhere? Oh, great. Oh, okay. That's really cool. Okay, so now let's go to Task Scheduler. Something really funky is going on. Why is my computer doing that? Is there something that's making it do that? Boom. So I look at all these. That looks BA Scheduler. That kind of looks legit. Google Update. That looks legit. Nothing. That looks kind of suspicious. Scoring engine. Okay, yeah. Let's go to nothing. What in the world is that doing? So, yeah. So we kind of look at the action that this thing is doing, and it's opening up a PowerShell script. PowerShell.exe/Windows style hidden/execution policy unrestricted. That is a terrible, terrible thing to have on your network. And you're going to want to get rid of that as soon as possible. If you see that, one of your computers is probably compromised, or you just have a really, really junky sysadmin. So yeah, we're going to want to go ahead and see what this is doing. So this is the PowerShell. It's opening PowerShell. It's running a few PowerShell parameters, and then it's opening a script. So we go to the script, and that's going to be in the temp folder. And it's going to be called notmalware.ps1. Not a suspicious name at all. So then, a really cool way to get to the temp folder. This is where a lot of malware keeps their certain files that they're using. %sign temp %sign. We're going to click enter on that, and we're going to kind of scroll through here and see. Oh, hey, there's notmalware.ps1. We're going to want to go ahead and delete that. Hopefully, if you're lucky enough, the attacker hasn't removed your permissions to delete that file. Otherwise, you're kind of up shit's creek there. So yeah, so now we're going to want to go ahead and disable this. Actually, let's go ahead and delete this. I don't think I got the scoring to work on this particular one, so you might not get points for that. But yeah, so far, to recap, we've turned on the Windows firewall, and there is a script that was running every now and again that would really move our mouse everywhere. So we went ahead and removed that from our Windows Task Scheduler and deleted the file. So yeah, so now we're going to want to go ahead and look at our see what users we have on our computer. So we can go over to Computer Management or Microsoft Management Console. We'll just use Computer Management for now. And then we're going to kind of scroll down to local users and groups. We're going to look at our users here quick. As I alluded to earlier, backdoor is kind of slightly suspicious. Typically in CCDC, we're going to have approximately 40-some user accounts on here. So what that means is you're going to want to learn how to script that to kind of go in there and change all the passwords to something else other than password one bang. So yeah, let's go ahead. We're at under normal circumstances, we would just delete it. Or for scoring purposes, if you want to get points for this, you just hit apply, and then that's going to score that. So yeah, another thing you might have noticed, our password was password one bang. Why do we have password one bang as our password everywhere? So we're going to go ahead and change that to something else. Let's go ahead and do password two bang. Okay, could do that for all these other accounts. Okay, the password has been set. Let's see if we're getting any points for that quick. And so far we've got points for deleting or disabling the backdoor user. Oh yeah, we do get points for deleting that scheduled task. So yeah, just go through once I'm, or right now if you prefer. And kind of comb through here and see what you need or what you don't need. I do believe the document that was open earlier said we must bring our firewalls back online. Okay, that's done. Thanos has added video games to our computers in an attempt to sabotage our productivity. Okay, we're going to want to take care of that eventually. I'm not going to go through how to do that. Most of you probably know how to do that. There are several unauthorized users being allowed RDP access to the host. Okay, we're going to have to look into that later. One of them says the default local admin account is enabled in the guest account. We don't have guests ever. So we're going to want to go ahead and disable the guest account as well. Get a couple points for that. Could disable that guy. What else should we do? Oh yeah, groups. They mentioned RDP access. There's a lot of users that had RDP access, which it appears there's no users that have RDP access. I don't know what happened there. There should have been. So that looks good. Okay. Telnet clients. Looks like everyone can telnet to our computer. Well, this is kind of strange. Okay. So let's go ahead and remove that, see what happens. Apply. Okay. So now that we're on the telnet thing, let's see if we have a telnet server running. Windows, actually, let's do services.msc. Let's pull this up. Gonna go scroll down through here. Oh, yeah, Telnet. It appears that we're running a Telnet server just on this computer. I don't know why. It's the worst service, one of the worst services that could possibly run on your network. So we're gonna go ahead and stop that guy. Disable the startup. All you gotta do to get to these settings is just right click on it and then you pull all that stuff up. Apply. Yeah, I wonder if we can, let's see, can we delete it? It doesn't appear that we can delete it. There's definitely a way to go through that some other time. Yeah, so let's see here. What do we got? What do we still have left to score? So the guest account was disabled. The vector was removed. In the services category, Telnet was stopped and disabled has been set properly. Okay, perfect. There's probably some way an attacker could, like, if they could use that for persistence somehow. I'm not sure. I haven't looked into it. But yeah, basically they send passwords in clear text, and it's not good or something like that. Okay, so yeah, that's where we're at right now. Let's go check the administrators group. Who has admin access to this computer? So right now it's just DSU and administrator. That's not too unusual. We could keep that there. We're not gonna go over any of these other guys right now. Oh yeah, task scheduler. We could have just edited all the tasks here earlier in this pane, but why not? Or why not just do it the hard way? Yeah. So that's some of the other things I looked at. Let's see, what else do we have on the to-do list? So that's actually not a thing, luckily. There's no password length requirement on the computer. Okay, this leads us to our next tool, which is called Local Security Policy. This is where all your security policies are going to be set and all that good stuff. So you go ahead and click enter. Typically, if your computer is connected to a domain, a lot of these things are going to be set by your domain admin. So yeah, let's kind of dive into these a little bit and see what we got. Let's go to account policies, password policy, enforce password history. So basically, if the notification comes up that says, we need you to change your password, you could enter in your old password and it would probably work. So that's not really enforcing password history. So let's go set this number to a slightly high number. It doesn't really matter. You can set it to, I think the greatest is 999. I just set it to 10 for the heck of it. Maximum password age. Let's see. Typically, you're going to see that at like 90 days. You can increase it to like 180. Like I said, it's kind of a big debate about about how long you should have your password. Minimum password age. You don't really need to set that. Minimum password length. I'm going to go ahead and set mine to 10. Hit apply. Store passwords using reversible encryption. Yeah, you're not going to want to do that. password must meet complexity requirements. You could turn that on if you want. It's kind of an archaic technique, honestly. Complexity requirements. So yeah, so to recap, we just, boom, we set our password policies. Probably not a first priority to do, but something you can do like a late game in CCDC or something like that. So if you look at this, there's some really, really outrageous lockout policy numbers. Like, if your account gets locked out, it's going to be locked out for 1,500 minutes. If you don't know how long that is, it's like, I think 3/4 of a day or something like that, maybe more. Account lockout threshold, 990 invalid logon attempts. So someone could sit there and brute force your password for 990 times before getting finally rejected and your account would be locked out. And you kind of don't want to have your account locked out for 1,500 minutes, so you might want to chuck that down to like maybe 5 minutes, because it's going to really slow an attacker down, and hopefully by that time your analyst is going to know what's going on. Let's kind of change some of these guys. I think current NIST recommendations recommend 100. However, there has been situations where I've seen like 2 million some password logon accounts as the norm. What that was coming from was like the dev group they were testing out an application, and they just kept, they didn't like stop their authentication stuff, and it just kept on going and got to 2 million in one day. Kind of a suspicious indicator that something's bad is going on, but what kind of lockout duration? Let's just set that to 5 minutes. Or you could put that to longer. I'm just going to put it to longer. So then we're going to go into local policies. Audit policy. We're not auditing anything really from our local security stuff. So look at that. Oh, what in the world? Audit account logon events. That might be a good idea to log that to your system information event manager. That's something your analyst is going to be interested in. Audit account management, directory services. You can go ahead and audit all this stuff if you want. A lot of it, you have to really, really kind of dig down into what you think you need and what you don't need. Like I said, we can probably spend an entire day just, or like a week or longer, just on what to actually send to your SIM. User rights, assignment. There's a whole lot of other stuff you can set to audit. Security options. Wait, that has nothing to do with audit, sorry. Security options, typically, like I said, you're gonna want, if you're on a domain, you're gonna want this guy to be disabled. Let's just go ahead and disable it right now for the heck of it, because we already have an admin account and we don't need two really. Unless you're using laps on your domain, which went over earlier. Sometimes some people recommend renaming your administrator account. It's kind of it's not a huge deal if you leave it there, in my opinion. Guest, yeah, like you can go through here, read all these. We could go spend a long time doing that. Windows Firewall with Advanced Security. Yeah, so you can just kind of scroll through here. I didn't really set a whole lot of settings elsewhere. So yeah. One thing we didn't look at was the actual firewall rules in our computer. So yeah, we turned the firewall on. Okay, that's cool. Apparently we're connected to a public network. It's also cool, I guess. So we're gonna want to go to allow a program or feature. No, wrong one. So in our search bar, we're gonna do Windows Firewall with Advanced Security. And it looks like that tab was even open on here. No, yeah, let's see. Yeah, that takes us to the same thing. So let's go ahead and look at this. Okay, there's a whole bunch of rules. Whether we need all these, maybe not. It looks like the telnet server, they're allowing people to inbound to our telnet server. We're gonna kind of want to go ahead and go delete that. remote desktop connection. Looks like all that stuff's blocked anyway, so we don't need to change that. A lot of this stuff we don't actually need. We'll go over all of what we do need and what we don't in a different module. Block all. Block all, and it's got an allowed thing right there. That's kind of, you're like, okay, what's that doing? Block out. Allow the connection. Allow all programs that meet the specified conditions. Yeah, so that's not really a good rule that you want in place there. So you're going to want to go ahead and delete that guy. Basically, you're going to be opening your network up to a whole lot of bad things. Allow none. It says allow the connection, so quite clearly it's not blocking the connection. So you're going to want to go ahead and delete that guy as well. Let's see here. Okay, so another big thing that you want to do is to get to this, you right click on this top guy and you click on properties, inbound connections, block all connections, apply, just because if I think it's, you know, bad stuff can get onto your computer that way. Do that for everything, block all connections. And then you can kind of let your outbound, oh, wait, let's see. I might have messed that up quick. Yeah, so you can allow outbound connections and things like that. Although the only problem, does anyone know the problem with allowing everything outbound on your computer at all? There's this thing that hackers, this Metasploit module that hackers like to use called a reverse HTTP connection or reverse TCP. What that does, it's going to call out of your computer once they manage to get a shell on your computer. It's going to call outwards instead of the attacker computer calling towards the client machine. So that's kind of one of the caveats, but you do need to allow all connections unless you're doing like application whitelisting or something like that, and you kind of want a more fine, granular way of allowing stuff out. So yeah, that's going to be our firewall. Like I said, we'll go over more in depth some other day. Let's see, what's our services at? So far, we're at 62.5% secured for all the stuff that I said. Let's see what else is on our list. Oh yeah, so go ahead and uninstall the Fortnite launcher. We didn't really fix that. There's some of that data going back on. So we fixed Telnet. But yeah, there's so many rabbit holes that you can kind of climb down once you get onto a box like this that you kind of really have to learn how to prioritize. Like in my opinion, you really want to get to the firewall first, and then go to your users and your groups and stuff, and change your passwords, and see who has access to remote RDP in your computer and things like that. So yeah, so we got 5 minutes left. I'm gonna go over this last slide on how to get good. That's a big term in our field here. No.
Okay, because I'm going to start powering down the Windows ones because we're having a little bit of IO lab issues if you haven't noticed.
Not really.
Power down all the Windows VMs.
Okay. Okay, so if you really are interested in the Windows stuff, like I said, Windows is really one of the main things in information security that like attackers and stuff target and use. And a lot of the talks I went to were mostly about Windows. So yeah, first off, you can build your own home labs, kind of like, build your own Active Directory domain. Just test your PowerShell scripts, all kinds of stuff. If you really want to really get good, build your own home lab. Like I said, we got the IA lab, luckily for us, which is honestly, do not underestimate the capabilities of this thing. It's really, really neat. So we're really truly blessed to have the IA lab. Let's put it that way. Practice, practice, practice. Study a lot outside of class. Don't sit there and spend 20 hours a week playing video games. Ask questions, lots of questions. People like me and everyone else, they really love answering questions for people that have questions. And there's not really a dumb question, so I take that back. There's some pretty stupid questions I've heard of. So yeah, I'll post these slides in the DefSec Slack if any of you want to see them. Hopefully, eventually, we'll get this Windows machine back online for you guys if we get our stuff resolved, so you can check it out later. So yeah, thanks a lot for coming. I hope you learned a little bit of stuff today about stuff. There's also a Linux 101 thing going on after this. I'm not going to be at it, but.
Good job.
Thank you. Thank you.
Way too much time to create. Took me way too much time to
Alrighty, everybody. So now we're going to go over the Windows half of our lesson, and hopefully we won't keep you here the whole time.
More Windows.
All right, the Linux half. Did I say Windows? Okay, so we're going to go over the Linux half of this lesson. So, Linux is the world's primary open source operating system. And I'll get to what I mean by that. So first off, no, I'm not going to full screen this presentation. You're going to have to deal with it because otherwise it's kind of weird the way that it does things on the screen. And hi, I'm Peter. So I've been working as a system administrator for Linux machines, kind of the same way Nick has been working as a system administrator for Windows machines for about a year and a half. Last year I was National CCDC Linux and Database Administrator. It's hard to administer web apps when you don't have a GUI, so I learned that the hard way. I was also the captain of the Cyberforce team, and this year I am a white teamer for Defensive Security Club. So the purpose of this presentation, we're going to be going over more how to use Linux than how to secure it. We're going to get into security, right? But it's hard to secure something that you have absolutely no understanding of. And when I came to DSU, I was given a Linux machine for an information security fundamentals class, and I had no idea what to do with it. So this is going to cover the basics, at least give you the tools to build off of and learn a lot more. Alrighty, so you guys are already logged into the IA lab, right? You should have a VApp called your username, DefSec Linux 101. Does everybody have that? If you didn't have the Windows one, and you don't have the Linux one, it's going to be the same process to get the Linux one, except for you're going to choose the one that says DefSec Linux 101 instead of DefSec Windows 101. Alrighty, so if it's not powered on, go ahead and power it on. I'm going to make sure mine is kind of reset to where it was. Everybody good as far as getting their Linux VApp powered on. If not, feel free to raise your hand. It's way easier to ask for help when someone comes over and pushes a button for you than it is to try to catch up after you've fallen behind. We're all good? Alrighty. So the basics. I'm going to grab my water. I have a cold, in case you can't tell. So the basics. Linux, or GNU/Linux as it's actually technically called, is a free and open source operating system. So that means that if you want to install Linux on your laptop instead of Windows, you don't have to buy a Linux license. Do you need help? Okay, perfect. You don't need to buy a Linux license the same way you'd need to buy a Windows license. It's free. You just download it and install it, just like a lot of programs out there. It's really nice. Open source means that it's not really so much of a secret, like what's actually running. In fact, all of the code that goes into building Linux is just out there on the internet, and you can look at it if you want to. You can download it, and you can change it however you want, and re-upload it out there as your own product, and you don't have to worry about copyright infringement. It's open source. Back in the day, before practically all of us here were even born, there was this thing called Unix. Now, Unix back then was the server operating system of choice, but it was not free, and it was not open source. And then there were a bunch of like really awesome tech hippies that were like, hey, let's make everything free. So they basically remade Unix, but slightly better and free. In 1991, the first Linux distribution was published. Linus Torvalds is the gentleman that made the kernel of the Linux operating system, kind of like the beating heart that keeps everything working. Richard Stallman and the GNU team. GNU is a recursive acronym that says GNU isn't Linux, or isn't Unix. So they just really didn't like Unix. GNU is not Unix. They built everything else with Linux. It's actually kind of funny how it's just called Linux, when in fact the kernel is so much less than the rest. Sorry about my voice. So, talking about Unix. Unix isn't Linux, but they're very similar. Most things work on both of them. You can copy and paste a working program from a Unix machine onto a Linux machine, and 9 times out of 10, it's still going to work. Unix isn't so much of a server operating system anymore. It's mostly used as a base for other things. So how many of you in here have Macs or have ever used a Mac? Mac OS is actually based on Unix. How many of you have iPhones? iPhones are running Unix. And also some really high-end, really expensive fancy routers and firewalls use Unix as the basis of their operating systems. So what's the point of having Linux in the first place? Why not just use Unix? Why not just use Windows? Well, Linux is free, right? And it's extremely stable. And so you know how every once in a while your laptop gets weird and you turn it off and back on again and it's just fine? Yeah, well, I've been working with 500 machines practically every day for a year and a half. And only once or twice has a situation come up where it was just weird running Linux and we had to turn it off and on again to fix it. It's really stable. It doesn't really have problems like that. It's enterprise grade, so big companies like Amazon or like the US government, which isn't really a company, can use this and not have to worry about it being kind of crummy and falling apart. And it's well supported, which means that since it's open source and there are all the people on the internet that can see it, there are a lot of developers that contribute to the project all the time. So when there's a security flaw found, it's often patched pretty quickly. Advantages and disadvantages versus Windows. Advantages. If you're using Linux as a desktop operating system, you don't have to pay for a Windows license. It's free. For a server operating system, Linux is still free. You don't have to pay for 1,000 Windows licenses for your 1,000 Windows servers, or however complicated the pricing goes. It's something weird. And it's super stable. I'd argue that it's more stable than Windows Server, but they're both good operating systems, and there's less overhead, I believe. If you have a Linux machine just sitting there not really doing much, it's using practically 0% of the processor, whereas Windows might be using 1 or 2%. If you have a laptop from about 10 years ago or something that you want to try using because it's got like a floppy drive in it and you think it's cool, Linux has such little overhead, and there are such lightweight distributions of Linux available that use such few resources that you can give older hardware new life to make it still usable. Probably still not quite as nice as a new machine, but like it'll still be usable when you don't have to use like Windows Vista or something. And you have more freedom. If you want to delete Windows with Windows, you can. You can tell Windows to just like suicide itself. But it's way easier to do that in Linux. It's like one command, right? You have a lot more freedom to do basically whatever you want in Linux than you do with Windows, which is an advantage and also a disadvantage. The disadvantage of Linux as a desktop operating system, you really can't play that many video games on there. A lot of them are meant basically just for Windows, and the driver support for graphics cards with Linux which really isn't there. Like you can get drivers, but they're pretty bad, and it takes a lot more expertise. If I were to just hand my mom a laptop running Linux, she would be like, what the heck am I supposed to do with this? Like, she wouldn't be able to install anything. She'd be confused about the file structure. Like, just trying to find something she downloaded, she'd be kind of confused about, right? But everybody grew up with Windows, so we're all used to that, right? They're just implemented differently. Another difference from Windows is the way that distributions work. So Windows comes in fairly linear versions. You've got Windows XP, which goes to Windows Vista. I forgot to list that one up there, but it doesn't really matter. Then it goes to Windows 7, Windows 8, Windows 10, sort of a thing, just like one after the other. Linux looks more like this. So it's kind of this crazy, chaotic mess. So in 1991, you have the original Linux, and within 2 years, you've got like what? This much other stuff, right? And all of these are, since it's open source, you can take it and change it and make it your own. So people do that, and then you end up with like a lot of weird stuff. And if you notice, this graph only goes to 2006. And I'm guessing it would be way, 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 way bigger if it was actually up to date with modern, like all the Linux distributions, right? Like Hannah Montana Linux is a thing where everything is like Hannah Montana-y, right, Chris?
It's literally the best. There's a website for it and everything.
All right, so there's a website for it and anything. Why are there so many different distributions? Why not just Linux 1, Linux 2, Linux 3, so on and so forth? Some of them are made for servers. What I work with at work is CentOS. It's an extremely stable version of Linux that doesn't change hardly at all for like 5 years, right? If there's a security patch, they throw a security patch at you, but otherwise they're like, we're gonna leave this so your programs don't break, right? So if you have a web server running and you don't want your website to break, you're gonna use one of these really stable distributions. For desktops, you're probably gonna wanna use something like Ubuntu, Debian, Fedora. They're meant to be a really nice interface that looks actually kind of a lot like a Mac interface. For security, you guys all have experience with Kali probably. It's just a distribution based on Debian that comes packed with penetration testing tools. And then for security, there's also Security Onion, which comes packed with defensive security and network monitoring tools. It's really cool. And phones. So those of you running iPhones are using Unix. Everybody here using an Android like me is using Linux. Of course, Linux on Android is way different than Linux on a server, but it's all still technically Linux. So if we're going to the iLab, this is just mostly for your information. Overview of what you're looking at. Debian 9 is what we're going to be using here. That's a Linux VM. Debian is a Linux distribution. 9 is a version of it. Debian 10 just released a bit ago, but I wanted to use Debian 9. pfSense down here is a router. That's so we can get networking going between the machines in this VApp and also to the internet if we would need to. Windows, because we're going to need a GUI. I think that's just a Windows 10 machine, kind of an older version of Windows 10. And don't use this one as in case something like failed horribly. Next time I'm not going to do that because it's probably just overhead in the IO lab. So let's start using the command line. Open a web console. I have it on HTML5. If you're using the Flash interface, just click on the screen on there. Otherwise, I'm going to close that and reopen it just so I don't need VMware. Where did it go? Oh, here we go. So you go here, you click the dots, scroll down, launch a web console. Web consoles are really neat the way that they work so well. Like, obviously, it's not nearly as nice as a regular, good old, like, physical screen. But for being just in a web browser, it's super cool. So we're going to log in. Oh, yeah, this is just like PuTTY that you use in CSC 150. This is the same sort of environment we're going to be using. We're going to log in as root, which is the administrative user, and with the password 1bang.
And for those of you who are currently having some issues, your VF's power on, I'm working on it. Hopefully I can get some of them powered on. If not, just follow along the best you can. We'll try to get sorted out for next time.
Alrighty. So everybody hear that? Cool. All right. So first we need network access. DSU has really good network security, and because of that, we need to authenticate before we can talk to the internet. Run this command. It's ./auth.sh. Then you provide your DSU username and password. I already did that, but I'm going to do that anyway, and it's going to be kind of confused. And it's probably going to be angry at me. But yeah, you should get something that looks like, hey, your user is authenticated. If it doesn't work, you probably typed in the password wrong. Oh yeah, and you're not going to see the password while you're typing it too. Everybody let me know, like, pretty much when you get done with this by like looking up at me and not blinking. Staring contest, but like with 50 people.
Can you zoom in on the console?
I can, yes. Oops. Oh, that's nice. Just a sec. Alrighty, has everybody gotten that going? It says user authenticated. So, if you haven't gotten it, that's okay. We can revisit it later if we need to. But honestly, I think this presentation has changed enough that this is no longer necessary. It's really nice to know that this is how you get to the internet. You can have things that will like be able to ping Google, but unless you run this auth.sh script or like authenticate through a web portal on a machine that has like an actual use your mouse and click around GUI, you're not going to be able to do all the things you need to, and you'll have like weird problems. All right, so we'll move on to the next one. Before we go too far into depth on what Linux actually like is and does, we're going to learn where we are. So if we type the command tree / capital L1, and we'll get into like what this is actually doing in a little bit. Ooh, capital L1. Should get something like that. Everybody get something like that? Perfect. Awesome. So you'll get something that looks kind of like this, right? This is a much prettier version, right? It's got pictures and everything. So you have all these folders and different names. So these are all folders for different things. Slash is a folder. So we ran the command tree /-L1 that says show everything that's in this slash folder, like in a list, right? So slash is like local disk C in Windows. If I open up Windows, right, I go to this PC, slash is here. It's right here. And this is really just a folder, right? You can click into it and go into it just like a regular old folder. That's exactly the same situation with slash. Now, inside of slash, we have different folders. Now, I'm going to call them things like /bin. Why do I call it /bin? Because bin is the folder name in the slash folder, right? And then you can talk about things that way. If there was a folder in bin called test folder, it would be /bin/test folder, right? So you're just talking about the path from the very beginning, that folder slash, which is like just the same as local disk C, right? So /bin would be just like saying C:\program files, right? It's the same sort of idea. But bin is full of binaries. That's what bin stands for. These are all executable files. And we're going to use these a lot as we move on in the presentation. Now, there's also /sbin down here. Sbin contains binaries that are only usable for administrative users. Anybody have any idea why they'd be in two separate spots? Go ahead and shout it out. All right. So, tough crowd. No, I get it. So we keep them in separate spots because it's just one extra layer of division between what an average user can do, what your regular user with no administrative permissions can do, and what the admins can do. Like physically separating those locations, right? Not physically, but pretty close. Then we have /dev. So another cool thing about Linux is that everything in Linux is a file. So to Linux, your screen is a file. this black screen that has the blinky flashing cursor on it right now, this Debian VM thinks is a file. Your keyboard's a file, your mouse is a file. If you have a graphics card, that's a file. It's really neat how all of these things are files, right? Those files are all stored in /dev. And since they're files, you can do things like edit those files, even though those files happen to be your screen, right? And when you do that, things break, but it's usually pretty funny. So then we have /etc, which has configuration files. So if you have some sort of program running, if you have a web server, the configuration files for your web server will be in /etc. You have /home, which is just exactly like your regular users directory, right? So if I go to C and users, that's like /home. It's a one-to-one example. If I am a user on a Linux system, I will have my home directory will be /home/ whatever my username is, /home/ p-angles, right? Just like in Windows. And then /media is where flash drives show up when you plug them in, right? Just like they show up as like E or F in Windows. It shows up in /media in Linux. /var is for files that change rapidly or substantially, just like log files. If you have a web server that's keeping track of every single person that goes to your web page and writes an entry in a log file, if it's a big web server like Google, that file is going to get really big. And /var is made specially to handle that, right? Or if you have a database and you're putting stuff in your database, it's going to get big. Var is meant to handle that. And finally, /temp. So you know how Windows, right? Every once in a while your disk is getting full, so you clean out all the temporary files that have been around for like a year and a half. Like how temporary is that, right? With Linux, there's /temp, which is a folder in the /, right? In the root directory, full of files that get deleted when you reboot your machine. So you can put a file in /temp, reboot, and it will no longer be there. So they are truly temporary files. It's nice that Linux actually like maintains that. So the Linux command line is this environment that we've got over here. And we're using a shell in the Linux command line called bash. Bash has been the default shell for like several decades, probably longer than I've been alive, which is really awesome, actually, since technology changes so fast. Like things that are good enough that they persist from one generation to another is really neat. Bash can be tab completed, which is way faster, more accurate than just to typing. It works by pushing the tab button. It's pretty cool. So if there's a command called clear, right, I could type CLEAR, which is 5 buttons, or I could type CL and hit tab, and it will fill in the word clear for me without any typos, and with me only having to type 2 letters and a tab, which saves me 2 letters of my valuable time. All right. It seems kind of goofy with just that example, but when you're typing like paths that are many folders deep, it's amazingly useful, just mostly for like the no typos sort of thing. So now we're going to get into like the structure of commands, right? In Bash, you have a command, and then after the command is an optional argument, and then a target. It's really neat the way that it ends up working out. So the command is the actual command you're running. So I've got the clear command up here. If I do la, oh, that's let's, and it's like, that's not a thing, and I type clear, it clears my screen, right? But clear is actually just a file, oh, wait, in user bin clear. So we said that /bin is where executables go. Well, some of them are in different spots, but in the most part, they're in /bin, right? So this command is an actual executable. Then there are arguments. Arguments slightly change the way that a command does things, right? It's not usually enough to make it do something completely different, right? Unless it's systemd, but you know, that's its own thing. But it augments it slightly. And then you have a target, whatever you're running the command against. It's also not always necessary. With clear, I just typed clear. But it can be a file, it can be a package, it can be a service or a process that's running, or it can be so many more things. And that's not official terminology, that's just the way I define them. So we're going to go over the command ls. So ls stands for list. It lists things in the folder or directory specified. Directory is just what we call folders in Linux. So if you type ls, you'll see auth.sh. That's the program or the script that we ran to authenticate to the network, right? So now if we want to add an argument to, we didn't specify a target for this, so it's just assuming that we're talking about our current directory. So now if we want to add an argument to this, if we do ls-l, which stands for long list, right? Now it's still listing the things in the current directory. It's still listing auth.sh over here. But it's got a whole lot more information there too. It's got file permissions, it's got who owns the file, it's got when the file was created and how big it is too, right? So it's still listing things. It's still doing what it did before, but it's slightly different than it previously had been. Now let's add a target. ls-l, or ls, not dash l, /var. If you type /va and hit tab, it'll fill in the rest for you. So what is /var again? Yes, it's stuff that changes size. It's a folder of things that change size. If we type ls/var, it'll say, hey, here's all the stuff that's in /var, right? We added a target. It's acting slightly differently because of the target. And then we can combine all three. We do ls-l/var, and it does a long listing of all the things that are in the var folder. Cool. Does that make sense? Sweet. I know I'm going pretty slow for people that know a lot of this stuff, but that's all right. Cool. So there's a special argument. There aren't many things that are just very special in Linux, but there's a special argument called --help. Now if we type cat --help, we get output telling us how to use the cat command, right? It's helping us with the cat command, right? We don't need to scroll up and down to read it because we can't really do that in a web console anyway. But it lists the structure. You see it says cat is the command. Yeah, sorry, it's not that big. It says cat is the command. And then it shows different arguments that you can use with that command. And then it says, hey, if you're using a target with this, it needs to be a file. So it's really neat. If you're using a command and you don't know exactly how it works, that's a good command to help you learn how it works. Cool. Whoops, that's a bit too far over. That's all right. I'll get it back where it was. I'm a good presenter. Alrighty. Cool. So, common commands. There's cd, which stands for change directory. Cd is exactly the same thing as going to Windows, going to here, and just double-clicking to change into the directory, right? If I want to change directory in Windows, click, click, there's that. If I want to change directory in Linux to say /temp, I'd type cd, whoops, wasn't in the VM, cd/temp. And you can type /tm, and then you can tab, and it'll fill it. All right, so does that make sense to everyone? So one more special thing about Linux, if you type cd tilde, which is right above the tab character, tab key, it'll take you back to your home directory, right? And your home directory as a regular user would be in /home. As the administrative user, we've got the same sort of separation going on like bin and sbin had. The home directory for the root user, the admin user, is in a different spot than /home. Cool, so if you type cd/temp, you'll go to /temp, cd tilde, you'll go to tilde. Now, another common command is touch. Touch makes an empty file if we just use it on its own. So touch test file.txt. If we do that, and then we run ls again, well, hey, now there's something else that's there. We listed it. If we do ls-l, it'll show us, hey, this test file.txt was created on September 10th. Does that make sense to everyone? Perfect. Now if we use the move command, mv stands for move. It's exactly the same as cutting and pasting. So if I go to my desktop, make a new folder, just go in here, and I want to make a new bitmap image. I don't like it here. I want it to go to documents. I cut and paste it. It's no longer in the new directory, but it is in documents. Someday I'm going to find that and wonder what the heck that is. So move is exactly the same way. So if we do mv for move, testfile.txt, you can tab complete this one really easily. I think you just have to hit T and then tab, and then you move it to the target of /temp, right? So you do that. If you run an ls again, it's no longer there, but ls/temp. Oh, I'll do an ls-l/temps, because since I'm zoomed in, it doesn't show. Test file is right there on the bottom, sort of cut off a little bit. Testfile.txt. Cool. Makes sense to everyone. So this one actually doesn't have a command argument target syntax. It's got a command and then two targets. The target of what you want to move and the target of where you want to move it to. Alrighty, so copy. Same thing as copy and paste, right? So if we want to copy test file back to our current directory, we would type the copy command, cp for copy, /temp test file, and then we'd type a dot. Dot is another one of the special Linux things. It means here, where you currently are. So if you cd'd to /temp, dot would mean /temp. Since you're currently in your home directory, dot means your home directory. So if we do that and we run ls again, testfile.txt is in our home directory. We run ls on /temp, and it's still there. ls-l/temp. Cool. So we just copy and paste it, right? Now, rm stands for remove. Remove is the command that will make you delete everything if you do it wrong. And another interesting thing about Linux versus Windows, Linux doesn't have a recycling bin. Once you delete something, it's gone, okay? You're not getting it back. And there have been times when I've been using Linux to do a program for class, and I accidentally removed the wrong file, and it went away, and I had to start over. And I'm sure Chase is nodding his head. That's happened to more than just me. So be careful with the rm command. But we're going to use it here. rm/temp test file will delete test file, right? So we've got our command, we've got our target, which is the full path to test file. ls/test temp. And it's not there anymore. Cool. So Nano. How many of you guys have used Nano so far? Most people. So Nano is just like Notepad in Windows, right? Type Nano and whatever you want to call a file. So if we create a file with Nano called hello file, what is that command? Awesome. It's nano hello file. Do I need to go faster or slower? Faster probably. Faster. Okay. What? Use cat to make the file. We'll get to that. Cool. So nano hello file. Type this thing. We'll use it later. Hello. This is me. I am a student. Have a nice day. Cool. So you type Control X to save, Y to say yeah you want to save it. Hit enter. It'll go away. I gotta scroll down because I zoomed in so much. Oh, yeah, it's gone. We're good. Cool. So, echo. Echo is kind of like printf in C. So if we do echo hello, it'll print hello to the screen. Make sense to everyone? It's really, really straightforward. It just prints whatever's in quotes. You don't need to use quotes. If you use double quotes, then it will recognize variables in the quotes. We're not getting into variables. If you use single quotes, it'll treat everything literally. Cat. Cat just prints out a file if you use it like in its simplest way. So if you do cat hello file, it'll just print out everything in hello file, right? You can't echo hello file. Echo prints out whatever's in quotes. Cat prints out whatever's in a file. Does that make sense? Cool. Less is really useful for looking at things that are too long. So you remember the -- help thing? Yeah, if we do ls -- help, it kind of scrolls by the screen really fast. We don't get to see what's actually going on there. But if we do, I guess, ls -- help, and then we pipe it into less, which we'll get into piping soon. Then we're given an interface where we can scroll using the arrow keys to read it, right? Or if we don't want to be able to edit the contents of hello file, we just want to read it, we can type less hello file. And we'll be here. There's not really much point to scrolling because it's only 4 lines, but you press the Q key to exit, and then you can type clear to clear the screen. Make sense to everyone? Cool. grep is really, really, really useful. It finds words in, I have here a file, but in just kind of a bunch of text, right? So if we use grep to find the word student in the file, hello file, the command for that is grep student hello file. And it will find the only line in hello file that has the word student and print it out on the screen. Now this is actually super duper useful, right? Like we can use grep for all sorts of things, not even just searching through files, but we can take output of previous commands and send it to grep. Grep will search through that output and find the words that we tell it to look for. And we'll get into that soon. So, cool. Move on to the next little bit. We have man. Man stands for manual. If we do man ls, it will use the less command from earlier, and we can just use the up and down arrows, and it will show us all sorts of help, far more help than is in the -- help command. And yeah, we can just scroll through and read it all. It's really nice. Press Q to exit again, and we'll move on. Cool. Now this one's a bit complex. We're not going to go very in deep about it. But systemctl is what we use to control services running on the machine. So a service is a program running in the background, either waiting to be used or carrying out tasks. So if you have a web server running on your machine, that web server is a service. It's a web service, right? And you can use systemctl to control that service. If you are running an FTP server, that FTP is a service, right? For the time being, we will just mention that this is a thing you can do. You type systemctl, stop, and then the service, start service, restart service, whatever it is. That'll be very, very useful for like actually administering things during competitions, right? Because if someone messes with your stuff and you need to restart it, right? That's a good way to restart a web server that's been broken. All right, so relative file location. So far, we've only been working like in the current directory and in /temp, right? You can also run commands on things in other folders, right? So we can cat hello file, right? And it's right there. We don't need a path to that. But if we cat and we start at the /, if we start at that very base folder that contains all the other folders, right? We can move on. We can cat things in /etc. The one we're going to use here is etc password. And we can print that out to the screen, right? So as long as you type the full path to something, you can run commands on anything, anywhere in the Linux file system. As far as input redirection goes, there are a couple symbols that redirect input, right? So if we do echo, remember that prints everything out to the screen, hello, and we do a greater than sign to redirect, then it didn't print hello out to the screen. If you type ls, you'll see there's a, oh, I did it wrong. It's fun. I had a plus sign in there that I forgot to backspace. If you look, it didn't print hello to the screen, it printed it to redirect.txt. So if we cat redirect.txt, we'll see it just says hello, right? So if you want to take the output of a command and put it in a file so you can look at it later, because there's a lot of it going on, you can redirect it to a file. Next, redirection. You can kind of take things and like feed it into commands as if you're typing it with a keyboard. I'm not really going to go over that right now because it gets a bit tricky. But that's also a thing that you can do. And then this is probably the most useful one. This is the pipe. So if we want to print the contents of hello file, what do we use? We do cat, I swear I can type, hello file. It prints it out, right? If we want to grep for student in hello file, but we don't want to just do grep student hello file, we can do cat hello file and then use a pipe and grep for student. And it will still only find the line where it says the word student. So what's different about the structure this time as far as command and argument and targets go? There is no target past the pipe. So we begin with a command and a target, right? And then it takes the output of that previous command and uses it as the target for what's after the pipe. And we can string a lot of things together using this pipe. We can go cat /etc password, just the same way we did that. And we can use the cut command to grab just the chunk that we want. Whoops. Then we can grep for everywhere that it says X. It's a big screen, it's all zoomed in, so I can't type it. And then we can use WC to count the number of lines, and then we can redirect error messages to dev null, which is pretty much just the trash can of Linux. Oops. Here we go. So there are 2 times that it shows up. It's cool. Sweet. And you can just string a lot of things together. That's the point of that. Right. So, and then this is really nice. Control C is cancel whatever's going on your terminal, right? So it's the same buttons as like copy and paste in Windows, right? So you can do ls-R. Don't run this yet, just by the way. This says recursively list everything that's in every folder starting at the very beginning of the file system. So if we do this, it'll run for a long, long time and be practically useless, right? If we want to stop it, type Control C and it'll stop. Alrighty, so now we're going to talk about repositories. So if you open a web browser and you go to the link repo.ialab.dsu.edu, you'll get this sort of thing. Now, all of these are different Linux distributions. So the way that we install things in Linux is really, really nice compared to the way that we install things in Windows. Repositories like repo.ialab.dsu.edu are where Linux gets packages from. So kind of like the Microsoft Store or the App Store, like you don't have to go out to the internet to find somewhere to install things. You just go there and get it, right? So we'll talk about actually installing things, right? You can install things like server software. If you want a web server, which we'll set up real fast here, you just run a single command to install a web server, or different programming languages. Like if you want to install Python or Java on a Linux machine, you just run a command and then you have Java on your machine. It gets it from the repositories. Or desktop environments. If you want to run Linux as a desktop operating system, you can get the thing that actually makes it usable with a mouse from a repository. So the last command that we're going to go over, I believe, is apt. So apt is a package manager. It stands for aptitude, which doesn't make nearly as much sense as like ls standing for list. So if we do apt install and then Apache 2 is a web server, it'll tell us it's already installed. I pre-did that, so we didn't have just like tons of people installing it all at once. But that is the command that you would run if you wanted to install a package, right? If you want to install a different package, you just do apt install whatever that other package is named, right? So if you want to see if the website is working, if the web service is running, you'll use the systemctl command that we talked about earlier. Systemctl. You can type systemc and tab, status, because we want to see whether it's running or not, and then Apache 2. It'll be like green, active running. Hey, this is working just fine, which is great, right? So now we're going to see whether it's actually like accessible to another machine, right? You type the IP AD command, which stands for IP address, of course, and it'll tell you what your IP address is. For me, I've got it as 192.168.1.104. So I'm going to go back to the iLab and I'm going to, go to the Windows machine, launch a web console, and log in with password one bang, because everything in the iLab is password one bang. And then I'm going to open a web browser and navigate to that IP address to see if the web server is actually working. So I don't care if it's discoverable. I'm going to open up good old Microsoft Edge. Who doesn't like Microsoft Edge? It's all good. I'm going to do 192.168. What was it? 1.104. And it's going to be the default page. So hey, this is an actual running website that is set up on a machine that you guys are in charge of. That's accessible to other machines over a network. Like, that's really cool. The way that it actually works, so easy, and all you would need to do is type apt install Apache 2. Alrighty, so now we're going to go fast over security things, right? So important files for security. Etsy password is where all the local users are defined. Etsy shadow is where all the passwords for those users are hidden, right? So those are in two different files. The usernames and passwords are in two different files because the system and a lot of different programs need to be able to see Etsy password to know whether a user is valid or not, but they don't need to be able to see a password to know whether it works. There are different processes that handle that. There's Etsy group, where all the groups and their members are defined. So like if your group has permission over a certain group of files or a certain set of files, that'll be the group that you're in. I don't know. Etsy sudoers and Etsy sudoers.d. So sudo is a command that stands for super user do. So that's exactly the same as right-clicking a program in the start bar and saying run as administrator, right? You're running something as an administrative user or with administrative privileges. So the people that are allowed to run commands with administrative privileges are defined in the Etsy sudoers and Etsy sudoers.d files. The bash history is the list of commands that have been run by a user. That's in a user's home directory. So if there's a user that you think is suspicious on a system, if you're an admin of that system, you can go to their home directory and look at their .bash history. And if they aren't very good at being sneaky, the things that they've been doing will be in there. There's the .bashrc and .bash profile, as well as the /etsy profile files. These are lists of commands that run when you as a user log in. You can see how that could be exploited by a malicious person, right? They could put a command in there that would make it so you can't do something or would mess with the way that you do things, and then it would run every time you tried to log in, right? There's /etsy rc.d, etsy rc.local, etsy rc.1.0.2. There are a lot of different rc files. These are lists of commands, kind of like bash rc, but they run when different run levels of the Linux operating system are reached. Like when you reboot it, or when you turn it off, or when you turn it on. So you can have commands that run whenever the system changes kind of its state, which also can be very easily exploited by an attacker. You have /var/log. We mentioned that log files are in var. If there's a service that's not working correctly because it's been attacked or it's just not working, it's probably in that log file. And then finally, there's Etsy cron tab, Etsy cron, like there are a bunch of different folders in cron, and var spool cron. Those are commands that run at intervals that are defined already. So security commands, there's the command w, which lists users that are logged into the machine, su, which switches the user, right? There's sudo, run a command as the administrator. Passwd is change a password. Get ent, get users and groups that aren't an Etsy password or Etsy group. Add user or user add, group add, they create users and groups. Del user or user del, they delete users. Del group is delete a group, and user mod is change attributes about a user, such as adding them to a group or changing the shell that they use or changing where their own directory is. As far as processes go, there's PS, which is viewing processes. There's top, where you can see processes using the most resources on your system. There's kill, which you can use to kill a process by its process ID. So if there's something you know is malicious, you can use the kill command to like stop the process from working. LSOF stands for list of open files. Since everything on Linux is a file, if there's something using network files or like sending traffic over the network, you can use LSOF to see the things that are sending network things. Otherwise, like in different directories and everything. IFTop is not on all machines by default, but you can usually install it using just like apt or a package manager. That shows network usage, kind of like regular top, sorts by what's using the network the most. And then service or systemctl, reload services, or like change them. So file permissions, since everything on Linux is a file, every file is owned by a user and a group. We're not going to go too far into this. You can change file permissions, you can change group permissions, and who owns permissions. We can talk about this later too. And we're getting a bit long here. So that's the end of the presentation. Any questions about anything? Cool. Thank you all for coming here. Does Nick have anything to say?
I got a few things just for everybody heads up.
Do you need the projector?
Yeah. Okay, so again, sorry about the iLab not working as well as we would like. We just got our own organization in the iLab this semester, so first day is always a stress test. Make sure you go to attendance.devsec.club and fill out that sign-up form so that we have your credential, your username for next week, so we can push stuff out to you automatically, and we'll have that done way ahead of time so that everything's working, we don't have any issues. Has everybody got this? I'll give it a few seconds. Okay. Oops. I had one more thing on here that I just added. Okay, so I know we had like a few new people this time around, so make sure you're on Slack, kernelpoppers.slack.com/signup. If you need to sign up for that, make sure you're on there. Once again, we've got students, we've got faculty, we've got prospective employers, so be smart about it. You can have a custom username, but make sure you have your full name attached to the account. But it's really important that you're on Slack for DevSec stuff because we post a lot of our content in there and you want to be informed. Most importantly, CyberConquest signups are now open. You can go to link.devsec.club/cc919. I posted that link in Slack before the meeting today. I'll probably post it again once we end here. So if you want to sign up for that, you can do that through that link. And if you want to put together a team, you can do that before you sign up too. So, any questions on any of this stuff? Okay, thanks for coming. See you next time.
That's probably a good strategy.
That was exacerbated by
Do you want to join in on that thread in general? Have you seen it? Get ready. Yes. It's a nightmare.
So we just want something.
doing
I don't know how much a core is per gigahertz. Yes, I don't know.
There were some people I
I don't know.
some people that I did. He knows how much.
Well, apparently, because that was the issue, because he didn't tell me. I didn't know any process, because I was like, we're having issues, like, okay, I'll try now.
So many reactions on it.
And I was like, oh, stuff on.
Wait, we don't have some HD?
Yes. But no one told me we only do this. That would have dragged, and there was other stuff because I'm like, we could get when we do it next, when we were comparing yours, just like put it in all your PSX boxes, and just had you have a connection to